We started a series in our previous lesson on linear motion where we discussed two of the basic concepts in kinematics, which are the speed and velocity. But for the purpose of this class, we are going to discuss the third concept, which is acceleration. And to start with, what is acceleration? Let me start by giving this illustration. When we consider a particular object that is in motion, okay, and we realize that the velocity of that object increases, then we can say that the body is said to have accelerated. So, in a layman's language, acceleration is therefore the rate of change of a particle's velocity. That is, when the velocity of a particle changes with respect to time, then we say we have acceleration, okay? Now, if that is the case, just like we saw in speed and velocity, we can calculate or compute acceleration as an average. Therefore, talking about average acceleration of a body, and it is said to have a formula which is a change in velocity all over the time, or the time taken for the change. And when we said it is the rate of change, remember, whenever rate is involved, then time is also involved. So this is the simple definition of acceleration. Let us consider two basic cases. We have final velocity, which is usually represented as v, okay, and we have initial velocity, which is represented as u. Initial velocity u and the final velocity v. The change in the velocity is given as the v is equal to the v2 minus v1, or in some text you see v minus u, where v is the final velocity and u is the initial velocity. And in some text you see v2 as the final velocity and v1 as the initial velocity. And of course, the time change denoted by the t, which is always equal to t2 minus t1. Okay, so let me ask a particular question. And what is the question? The question is, what is the acceleration of the body that is undergoing uniform velocity? What is the acceleration of the body undergoing uniform velocity? Before we can answer this question, we have to understand what uniform velocity is. When we say uniform velocity is defined as the motion of an object whose velocity increases when the velocity of a body increases by an equal amount of time in equal interval of time, then we say that the body has undergone uniform velocity. Okay, let me rephrase it, or let me state it in this form. Uniform velocity is said to occur when an object or a body undergoes an increase in velocity by an equal amount in equal interval. All right, so we say the body has undergone a uniform velocity. Now, going back to the question, we said, what is the acceleration of a body that has undergone or that is undergoing uniform acceleration? Now, you realize that before a body can even accelerate, its velocity must increase. Okay? Its velocity must increase as time changes. So, as time changes, as there is a change in time, then there is also a change in velocity for acceleration to occur. But in this case, when we talk about uniform velocity, we said uniform velocity, it occurs when the acceleration of the body increases at equal interval of time, at equal amount of time. So that means there is no change in time. So if an object moves from point A to point B, okay, covering a distance of let's say 5 kilometers, okay, 5 kilometers in 2 seconds. In 2 seconds. So if it moved also from point B to point C in another 2 seconds, from point C to point D in 2 seconds, then we say that the body has undergone uniform velocity, okay? But in the case of acceleration, we said a body is said to accelerate when there is a change. As there is a change in velocity, there is also a change in time, okay? So in conclusion, any body that is undergoing a uniform velocity is said not to accelerate. Is that okay? Because there is no change in time. Are you getting what I'm trying to communicate? Yes, I'm sure you are. So a body undergoing a uniform velocity cannot be said to accelerate. This is a likely exam question, so you take note of that. Okay, now let us take for instance, if suppose a car increases its velocity, okay, increases by 5 kilometers per hour, okay, from 5 kilometers per hour rather, and then to 9 kilometers per hour in how many seconds? In 3 seconds. So this particular car increases its velocity from 5 kilometers per hour to 9 kilometers per hour in 3 seconds, right? And you realize that, okay, let's say from it also undergo a velocity change from 9 kilometers per hour to, let's say, 13 kilometers per hour in 5 seconds. Okay, the difference in the distance here, of course, is the difference in this distance here is 4 kilometers, right? And the difference between this distance as well is 4 kilometers. But the time it took for the first journey, it took 3 seconds. While for the second journey, the same distance, it took 5 seconds. Realize that because the time change for both journeys are not the same, even though they cover the same distance, then we say that the acceleration of the body is non-uniform. Is non-uniform, okay? And of course, if you know if something is uniform, all right, the opposite of it is non-uniform. So, but when the acceleration of a body is constant, if the acceleration of a body is constant, then we say that the acceleration is uniform, okay? But in the first scenario here, in the scenario I gave over here, the acceleration is not constant, and that is why we said it is called a non-uniform acceleration. But on the other hand, if the acceleration is constant, then it is called a uniform acceleration. Okay, now this is where we are going to wrap it up on this lecture. Okay, in our next class, we are going to discuss interesting concepts under the topic equations of uniformly accelerated motion. So see you in our next class. Meanwhile, if you have questions for me, you know how to access the platform. Just drop the questions there, as I would always be there to attend to all your questions. Bye for now.